Okay, I am now going to use Newton's method to find the fifth root of 100,000 and 125. Okay, so you can see the other video if you want to understand sort of where the formula for Newton's method comes from, and that is that we will say that x sub n plus 1. So the next step is found by taking the preceding step and then subtracting from that f of x sub n all over f prime of x sub n. Okay, so that may seem like a bit of a mystery first, but you will see how this works out. I think it's helpful to think about this in terms of like how it works with a function. If we have an axis and then we kind of convert this into a function notation, I'd say, well, f of x is going to be equal to, well, if I say, hey, there's some solution to this, right? There's some solution. That's some solution x. If I raise both sides to the fifth, I get x to the fifth is 100,000 and 125. And then if I wrote it thusly, that it's x to the fifth minus 100 and 125,000, right? If you think about what that is, the solution, the zero for this, will give me that desired value, the decimal equivalent of this that I'm looking for, all right? So going from the original stated problem into this function notation, it's not a difficult skill, but if you think about writing it equal to x and then getting this number by itself and sort of unpeeling it and then setting it equal to 0, you'll get a function that is written like this, all right? So if you think about what a graph like that would be, x to the fifth is going to look like this, and then if we translate it down a good 100,000, it's going to be essentially something like this, all right? And what we're looking for is, hey, well, what is that 0? Well, Newton's method means is just simply that if we get close by it and we get a point there and then we use the slope of a tangent line to find a closer point and then repeat that, we get closer and closer and closer. You can see the other video on how that really works, but we're going to put this into action by solving based on this function. So what is the derivative of this? Because we need the original function and its derivative. The derivative of this is 5x to the fourth, and that drops to 0. So there's the derivative. What's our point that we're going to get close to? Well, if you look at this, the fifth root of 100,000 exactly is 10. So I'm going to say, let's pick a point 10. It actually would be slightly below here. So there's my value 10. So I'm going to say, well, if x sub 1, my first guess is 10, then x sub 2 is going to be, the way this works with our little index numbers here, if this is 10, then if this is the value of 10, but if this is our x sub 2 guess, then I just go back to what is x sub 1. So it's just going to be 10 minus, and then f of 10, and then f prime of 10. Okay, well, what's that equal to? It's 10 minus, what's the original function when I put in 10? In my original function here, that was x to the fifth minus 100,000 and 125. X to the 10th is 100,000. When I take away 100,000 and 125, I get negative 125. I can't talk and do math at the same time, I'm sorry. So plug it in, check it out, see, that's what that is. Then f prime of x, when I plug in 10 here and I raise it to the fourth, that's 10,000. When I multiply it by 5, that's 50,000. Okay, well, 10 minus a minus is going to give me a plus, so that's 10 plus, and when I start canceling, I cancel a 1 and I cancel a 5, and I get a 1, and I get 25, and 25 over 10,000 is 0.0025. So x sub 2 is equal to 10.0025. Well, what's x sub 3 then? X sub 3 is going to be this original x2 minus, and then f of 10.0025 all over f prime of 10.0025. And you can just take a calculator and you can start typing that in. I'm getting a little bit of glare. See if I can make this work. I hope so. So I would turn it on and quit out of that and clear it. And I would say we can do this, I guess, the first way, where I would be 10 and then minus, and then it's going to be in parentheses 10 caret to the 5th over, and then minus 100, 125, close parentheses, then divided by parentheses 5 times 10 caret to the 4th. Okay, so this is just what I did a moment ago. Oops, get that out of there. And you'll see, there we are. Okay, so now I'm going to do minus, and then I'm going to do in parentheses second answer caret to the 5th, then over, and then minus 100,125, because this is our original function. Go back to the original function, divided by, and then it's parentheses 5 times second answer caret to the 4th over, close parentheses, hit enter, and there it is. All right, I'm only going to do this this time, because if you check the actual answer, that is insanely close. And I then got x sub 3 equals 0.0249875. Okay? It is interesting to note that there's a really handy way to do this on the calculator. Okay, so I'm going to show you that right now. And that is, if we go to the functions, and it's worth knowing, if you haven't seen this, there's a good video out showing you how you can type in a function, and you can do the derivative in your head and say, oh, that's 6x to the 5th and not minus 75x to the 4th. There, I've typed it in, but you can also have the calculator do it, and it's under math menu, and you get this little thing where you get d over d, and you type in the variable, you type in the function you want. I chose it to take the derivative of y1, and then it tells you if you're doing it at a specific value, you type in that value. If you want it to be a function, you type in a variable x. So I did that down here, and I went all the way down to y7. There's my original function that we've seen, okay? And I'll put its derivative in y6 just to show you how that works. And I would just go math, and then I scroll down to 8, option 8. There's the derivative. When I hit enter, here I get these little pigeonholes where I can put in the values. I'm going to type in x. Then I wanted to do y7, and you find that on the vars key right there. So I hit the vars key. I have to go over to yvars. I have to hit function or number 1, and then I go down and I hit number 7, and you'll see there appears magically y7. I go over here, I want it to be a function, not one fixed value. I hit y, and so that's what y sub 6 is. I did that earlier, and I did it with y8, so these are the same exact thing. Then, this is